Okay, I'm going to go through this a little bit slowly because I really need these angles to sink in. And this is what I really want you to focus on for today and for tonight. So if you're looking at the week at a glance or anything like that, the calendar, it says that we're also going to do velocities today, but I'm actually going to wait and do that tomorrow because I really need these angles to sink in to what's happening. Okay. Today we're going to talk about what we call radians. It's the other setting in your calculator that you've seen on there before, and we're going to talk about that today. And at first, radians is going to feel very uncomfortable to you, and you're going to not want to use it very much. But I promise you'll get to a place where you start to hate degrees and love radians. And so eventually we'll get to a place where I'll give you a question in degrees and you'll all be like, oh, can you just give it to us in radians? Okay. Right now it's going to feel the other way, but I promise you it happens every year. Everybody ends up really liking radians better than degrees. Okay. Okay. So we're going to be drawing some angles on a coordinate plane. So let's start by drawing a coordinate plane where we have our x-axis and our y-axis. Okay, so just normal coordinate plane with x and y-axis. Okay, we're going to talk more about this a little bit later, but just let me remind you that when we talk about this, we talk about quadrant 1 and quadrant 2 and quadrant 3 and quadrant 4. And again, that's going to get more important later on down the road, but for right now, just let me remind you that that's how we label our quadrants. Okay, so to draw an angle on a coordinate plane, I'm going to start with the vertex. Okay, so an angle has three parts. It has a vertex, or kind of a starting point, and then it has two sides. And those two sides are going to open and close and make bigger and smaller angles. Okay, so this right here is what we call the vertex. And what's special about it on the coordinate plane is that it is always at the origin. Okay, that vertex is always at the origin. Okay, so part number 1 of an angle is the vertex. Part number 2 is going to be what we call the initial side. Okay, the initial side for an angle on a coordinate plane is always on the positive x-axis. Okay, so that's what we call the initial side. And it is always on the positive x-axis. The initial side, which is always on the positive x-axis. Okay, then the third part of an angle is going to be the piece that opens and closes. Okay, so that's what we're going to call the terminal side. And eventually I'm going to quit drawing the initial side, and I'm only going to draw the terminal side because the initial side never moves. It's always right there. Okay, but I can draw the terminal side kind of anywhere. And it's going to make an angle for us. Okay, so that right there is what we call the I can't spell. I've written this word all day long. Terminal side. Okay, and that's going to be the side that opens to make the angle. That's going to be the one that I'm going to draw more consistently. Okay, that's going to be the one that we're going to measure. Okay, so I'm going to say just an estimation of that angle, that it opened this direction, which is going to be important here in just a minute, and made, let's say, a 60-degree angle. Okay, might be a little closer to 70, but let's just pretend it's a 60-degree angle. Okay, I'm going to say that it's positive 60 because positive angles on a coordinate plane open in a counterclockwise direction. Okay, so when you think about these, think about like the hands of a clock. Okay, and so one is staying still, and the other one is moving around the circle of a clock. Okay, so that's what we're looking at here, is this angle moving around that circular face of a clock. Okay, if it's opening counterclockwise, it is going to be positive. Okay, I'm going to use a different color, and I'm going to draw an angle down here that open this direction. Okay, if I go that direction, then it's going to be a negative angle. So I'm going to say that that is negative 60 degrees. Okay, so negative angles open clockwise. Okay, so depending on which direction your terminal side went, that's how you know if your angle is positive or negative. Okay, any questions so far? Okay. All right. We're going to draw kind of a lot of axes today. Sorry, but I need a new axis. All right, so jump down just a little bit so it won't be confusing. Let's draw a new one. All right, so draw some more axes. Okay, so there's my x-axis and my y-axis. Okay. All right, I'm going to put my vertex at the origin. And I'm going to put my initial side on my positive x-axis. Okay. Let me start by saying that I'm going to take my terminal side and I'm going to draw it just exactly on top of my initial side. Okay, it's kind of hard to tell because they're the same thing. Okay, but I didn't move at all. If I don't move at all, I can call that a 0-degree angle. Okay, so we're going to start right there at 0 degrees. Okay, think back to geometry. Okay, let's talk about a circle. Do you remember how many degrees a circle has? 360, that's right, good. A circle has 360 degrees. Yeah.
I was just wondering, since if you put one side like to the right is 0, if you put on the opposite, would it be 180?
It will be 180. Yes. Yeah. Very good. Yeah. Absolutely. Yep. Okay. All right. So let's go with this circle idea for just a minute. All right. I'm going to open counterclockwise. I'm going to go all the way around and make a complete circle of my clock. And my angle is going to end up right back there in the same place. I can call that now also a 360-degree angle. Do you see how they look exactly the same? Okay, so 0 and 360 are really the same angle, the same terminal side, I should say. Okay. All right, here's kind of a weird idea for you. I could go around 360 and keep going and go around again all the way back to here. So I went around 360 degrees and then I went around another 360 degrees. So I'm now at 720 degrees. So all of those are the same name or different name for the same angle. Okay? And you can go as big as you want. I could go again and be at 1080. I could go again, I could go again, I could go again. Okay? So there's an infinite number of names for that one angle. Okay? All right. Now let's go to this idea. Okay? Now I'm going to say that I remember from geometry that a line has 180 degrees. Okay, I'm going to change colors. All right, so what if I go from my initial side around to here, and I stop and put my terminal side right there? Okay, do you see how it made a straight line? Okay, so how many degrees do I have now? 180, that's right, good. Okay, so this is going to be a 180 degree angle. Or you can think about it as the whole way around is 360, so halfway is 180. Okay, all right, change colors again if you're doing colors. All right, let's say that I go from my initial side here and I stop right there on my positive y-axis. That's right, that's going to be a 90 degree angle. Good, okay. All right, you can think about it one of two ways. We went halfway to 180, so halfway would be 90, or you can look at this as being a little right angle right here. And that little right angle makes a 90 degree angle. Okay, so 90 degrees is in what I'm going to call my crimson pen because I'm an Alabama fan. It's probably more maroonish, but we're still going to call it crimson for my class, okay? All right. Plus, Alabama had a big night last night. If you didn't watch, Alabama got won the Heisman Trophy, so we're going to call this my crimson pen today. I also wear my Alabama shoes today. Do you like my Alabama shoes? Fairhounds shoes. Yes, there you go. Okay. All right. So we're going to call it my crimson pen for today, okay? All right. All right, last color pen. I've got one axis that I haven't done. All right, I'm going to go all the way from here, all the way around. I'm going to go past 90. I'm going to go past 180. And I'm going to go right down here to this angle on my negative y-axis. Okay, so I passed 90. I passed 180. And I went another 90 degrees. Where am I now?
270.
270. That's right. Good. So this is going to be a 270 degree angle. Okay, how are we doing? Okay, and again, there's all kinds of little angles along the way as you go. Okay, like I could draw one right here that's like a 30. Okay, I could draw one kind of halfway in between that would be like a 45, and a little bit higher up would be like 60. And then I could go over here and have like 120. My pencil's not cooperating. Maybe I should switch over to my crimson pen. Let's try crimson pen instead. Maybe it's more like me. All right, so there's 120. Whee! All right, 135, like 150-ish, 180. Keep going. Do you see what I'm doing here? Okay, so as you go around, you can keep having more little angles all the way around. Okay, and again, you can get bigger than 360. You can actually get smaller than 0. That's where we're going to go next. Okay? All right, we're going to draw 2 more sets of axes. Here we go. Here's one. All right, draw me one more clean set of axes. Okay, all right, vertex. All right, I'm going to stop drawing my initial side. Okay, you know where the initial side is now. It's over here on my positive x-axis. Here's my initial side. Okay, but let me start with, again, saying that right there, if I haven't gone anywhere, is still 0 degrees. Okay, this time I'm going to measure clockwise. All right, jump back up here. What does it mean when I open clockwise? What's going to happen? I'm going to have negative angles. That's right. Okay, so my measurements now are going to be less than 0. They're going to be negative. All right, so let's go all the way around. So this time I'm going to go clockwise, all the way around. And that's going to put me at negative 360 degrees. Okay. All right, change colors. All right. let's go to this one on my negative y-axis. Go right there. Okay, so earlier I called that angle 270. What am I going to call it now that I've gone clockwise? Negative 90. Good. Very good. Okay, notice that we measured just that 90 degrees right there. There's my right angle. Right there. So negative 90 and 270 are the same angle. Okay. All right, change colors. Back to my navy pen. All right, let's go from here. Let's go clockwise around to here. Okay, all right. What's that angle measure going to be now that I've gone clockwise?
Negative 180.
Negative 180. That's right. Good. Okay, so this is negative 180 degrees, which is the same thing as positive 180 degrees. All right, last one. Back to my crimson pen. All right, this time I'm going to go from here, past 180, all the way around to here. All right, what's that one going to be now that I've done it clockwise? That's right, good. Negative 270 is the same thing as 90. Good. Okay, and we can keep going, all right? If I went around twice, I could call it negative 720. If I went around 3 times, I could call it negative 1080. And you could keep going forever and ever and ever. They all have an infinite number of names. Okay? This is a lot to take in today. All right. The last axis I'm going to draw is now going to show you how to relate degrees over to radians. Okay. All right. So draw me one more blank axis. Last one. Okay. The trick to radians is to know that 360 degrees is equal to 2 pi in radians. Okay, now pi is still just pi. Pi is still 3.14. But we're going to leave it as pi in these so that we have a more exact answer. Okay, so don't multiply by 3.14, but it's still 3.14. Pi is just pi. Okay. The other thing you need to know about radians, other than it will almost always have pi in it, is that radians has no symbol. Okay, so if you're looking at something like 36 and you don't put the degrees symbol on it, then that means 36 radians. Okay, so be sure when you're working problems that you put the degrees symbol on things. So degrees has a symbol, radians does not. Okay, so if you see something like 2 pi and there's no symbol, that means you're working in radians. Okay? All right. So let me start again. I like to start at 0. All right. 0 degrees is the same thing as 0 pi in radians. Okay, because 3.14 times 0 is still just 0. Okay, so 0 is 0. Sometimes in radians, they will just call it 0 and they'll leave the pi off. And that's okay too. Okay. All right, let's go all the way around. I'm going to go counterclockwise. And I'm going to make that same angle, but after I've made the full circle, which is 360 degrees, or 2 pi in radians. Okay, so that angle can also be called 2 pi. Okay. All right, change colors. All right, I'm going to go to 180 next. Okay, so I'm going to go counterclockwise in my navy pen, And I'm going to go right here to 180 degrees. Okay, 180 is half of 360. So what's half of 2 pi going to be?
Pi.
Pi, that's right. Okay, so the numbers still work out. Okay, if 180 is half of 360, then pi is half of 2 pi. Okay. All right, change again. Maybe green this time. Okay, I'm going to go and do 90 next. All right, so I'm going to open counterclockwise, and I'm going to say this is my 90-degree angle. 90 degrees is half of 180. So in radians, that's going to be half of pi, or what we will call pi over 2. All right, last one. Back in my favorite crimson pen. All right, this one's going to be kind of weird. All right, but I'm going to go counterclockwise. I'm going to go around past 1 pi and then another half pi. So what I'm looking at here is 1 1/2 pi, or what I'm going to call 3 pi over 2. Right? They can also go the other way, and I'm not going to ask you to draw all of those, but they can also be measured clockwise. Okay, so I could also measure from here to here and say this is negative pi over 2. I could measure on around and say this is negative pi. I could measure on around, so that's negative 3 pi over 2, and all the way back around to negative 2 pi. Okay, so they can work positive and negative. They can also wrap around many times. So just like with this one, if I went around 2 pi and then another 2 pi, I would be at 4 pi. I could go again and be at 6 pi. So it's okay to be bigger than 2 pi and smaller than 0. Okay? Okay. So I need you to kind of let all those angles sink in. Okay, but I also need to today teach you how to convert from radians and degrees. Okay, so mathematically, here's what I need you to know today. All right, let's start with convert from degrees to radians. Okay. This relationship right here of pi being equal to 180 is what we're going to use to be able to convert. Okay, we could use 2 pi and 360, but this one's going to be easier to use. So this is the one that we want to use the most. Okay, so to convert from degrees to radians, I'm going to multiply by pi over 180. Okay, radians almost always, I hate to say always because sometimes you'll see them without, but radians almost always have pi in them, and they're in the numerator. So if I want to change 2 radians, I'm going to multiply by pi being in the numerator, so pi over 180. Okay, so let's try one. Let's start with 30 degrees. All right, I'm going to take that 30 degrees, and I'm going to change it into radians. All right, so I'm going to multiply by pi over 180. Okay, now I'm going to keep pi in my answer. I'm not going to multiply by 3.14. I'm just going to keep it the way that it is. So I'm going to do top times top and bottom times bottom. And then I just need to reduce my fraction. Okay. Now the calculator can help you with the reducing, especially if you get to one that's kind of hard numbers. But just ignore the pi that's on there for a minute. Okay, so to do that, I'm going to do 30 divided by 180, and then I'm going to use math and frac, math and number 1. Okay, that's going to reduce my fraction of 30 over 180 to 1/6, and so my answer is going to be 1 pi over 6. Okay, so don't put the pi in your calculator if you're using your calculator to help you reduce. Just put it back in your answer at the end. Okay, all right, let's try one more. Let's do 400 degrees. So I want you to see one that's bigger than 360. Okay, bigger than 360 is perfectly fine. Okay, I'm going to do the same thing. I'm going to multiply by pi over 180. Okay, top times top. Bottom times bottom. Okay, again, if you want to reduce by hand, you can. If you want the calculator to help you out, I'm going to do 400 divided by 180, and I'm going to do math and number 1, math frac. I'll reduce that down to 20 over 9, okay, which will give you 20 pi over 9. Okay, any questions on that? All right, last thing. Let's go the other way. All right, so we're going to now convert from radians to degrees. Okay, I'm just going to do the opposite, and I'm going to multiply by the reciprocal 180 over pi. Okay, let's say that we're working with pi over 5. Okay, the way that I remember which way to go is if I'm trying to get 2 degrees, I want pi to go away. If I'm trying to get to radians, I want pi to be in my numerator. Okay, if I'm trying to get to degrees, though, I want pi to go away. So I'm going to multiply by 180 over pi, because what's going to happen to my pi's right there? They're going to cancel out. That's right. One in the numerator, one in the denominator is going to cancel out. And then I'm going to have top times top and bottom times bottom, which gives me 36 degrees. Okay, last one. Let's do one where we have another number with it. Let's do 3 pi over 4. 3 pi over 4 is going to be really important in the next couple of weeks. We're going to use that angle a lot. Okay, again, I'm going to multiply by 180 over pi because I want pi to cancel out. Okay, if I do it the opposite way, I'm going to end up with pi squared. I don't want that. Okay, so I want pi to cancel out. I need pi to be in the denominator. All right, so top times top, 3 times 180 gives me 540. And then I'm going to divide by 4. Gives me 135 degrees. My 5 came out kind of funny there. Okay, any questions on that?